Okay, today I'm gonna be answering question 1 from the chapter number 5. So let's start with the first question, which is gonna be part A. Okay, so the question says the following. In a modified version of the car and bucket, the angle of the slope is 36.9. So let's write that down. 36.9. And the bucket weighs 215 newtons. So that's going to be the mass. Let's write that down as well. The car moves up the incline and the bucket moves downward, both at a constant speed. The cable has negligible mass and there is no friction. What is the weight of the car? Okay. So for this question, I'm going to go ahead and make a free body diagram. This is for the bucket. So the bucket has weight 2. This is the bucket. Let me label it. And let's do one for the car as well. So we have this one over here. There is no tension. So we only have our x and y coordinates. There's 6.9 and then this one. Okay, and this is weight 1. So let's see. Now that we have this and that, we can see that we can use the following formula that we've been using all along. And now let's plug that into let's see what we have and what we don't have, and let's see if we can figure that out. So let's see. We don't have a tension, so we know that our tension is gonna be 0 because that's the negligible mass. So let me go ahead and just write that down for the bucket. Now for the car, we do have tension. So let's get that, and then I'm gonna plug this into my calculator. This is gonna give me 0.60, and this is gonna be of the cart. This is gonna be the cart. So now when we see this formula, we can see that we can start plugging in something into it. So let's start by putting numbers down. So we have the final, we have our tension, then we have this that we already have that. 36.9 equals 0. So when we plug that in, let's see what we have. Let me start plugging in. We have the final, which is that what they gave us, and we have the tension of the first one. So what would that be? To answer our question is, what is the weight of the car? So the weight of the car, since we plug it in and then we solve by the weight of the car will be 358 newtons. That's the weight of the car 1. Okay, that will be the part A. Now for part B, let's see what we have for part B. Let's look at our question. What does it say? Part B, what is the tension in the cable? So we already know the tension of the cable because it's going to be the same one. So the tension of the cable, it's going to be 250 newtons, the one that they gave us. This is going to be part B. Now for part C, we have a similar question, but it changes the angle of the slope, and the bucket remains at rest. That the tension is negligible and is 155 newtons. There is no friction. What is the weight of the car? So now they're asking us the same question, but just with different values. So let's go ahead and use the same formula, and then just plug it in. Okay, now we have this angle, which is different. Sorry, 26. And then our tension. There we go. So let me plug that in. So we have that, and then we're using the same of 26. That will give us the weight. Now put this in our calculator. Then we divide that by that, which cancels out, and then we're left with the weight. It's gonna be 354 newtons. That's gonna be our part C. Now let's see what's the next question for our part D. What is the combined weight of the cart and bucket? Okay, part D. They're asking us what is the combined weight. So we're gonna use the combined weight formula, and then let me put it right here. Combined, which is gonna be the weight of the car and the weight of the bucket. So for that, we have that the combined weight. It's gonna be 354, which is what we got previously, plus what we got in the last one, which was 155 newtons. And this is gonna give us 509 newtons, which is gonna be the combined weight for both of them. This was for part D. Now let's do part E. Let's see what the question says. Part E, sorry. To construct a version of the car and bucket, but with a slope whose angle can be adjusted. You use a car of mass 181 kilograms and a bucket of mass 59 kilograms. The cable has negligible mass and there is no friction. What must be the angle of the slope so that the car moves downhill at a constant speed and the bucket moves upward at the same constant speed? So let me do a free body diagram because now we have a slope. So this might be a little more, not complicated, but it's just better when we see everything. Okay, let me just do it like this. Another one like that. Okay, so this is gonna be our cart, and then right here I'm gonna put the bucket. Okay, so the angle can be adjustable, so we don't know the angle yet. We know that we have normal force. This one over here. We have this, which is gonna be the sun. Then on the x direction we have that as well. Then this is gonna be the bucket, and then tension of the bucket. Okay, so now let's see what we have. We have that the weight of the cart, it's gonna be 181 kilograms, and that the weight of the bucket, it's gonna be 59 kilograms. So what we could do is that we can use the formula to find the angle. We have used this formula all along over this chapter, so it's just gonna be the same formula. In this case, we're gonna use sine because we use trigonometry, and that will be the one that we need to find in this case. So let's do that, and then we're gonna do it with the two masses. So let's get that. Inverse sine of 59 kilograms and then 181 kilograms, which will give us the answer, which is 19. The angle for this will be 19. Let's see what the next question says. Part E, part F. With this choice of angle, what will be the tension in the cable? So now we have the angle, and then let's look for the tension, part F. So we have the formula for tension. Let me write it down. Tension, it will be mass times gravity. So let's see what we have. We can just plug it in. We have the mass of the bucket, which is going to be 59 kilograms. And we have the gravity, which is going to be 9.81. meters per second square, which will give us that the tension, it's gonna be 578 newtons. Okay, now for part G. In this situation shown in figure 1, let angle be the angle of the slope, and suppose there is friction between the car and the track. You find out that if the car and bucket each have the same weight, they remain at rest when released. In this case, what is the magnitude of the friction on the car? So let's see. They're asking us to solve basically for the friction force. So let's see what we have. So in the question they gave us that tension was gonna be the y direction and the friction force, and that the weight was gonna be the y direction as well and friction force, because they equal the same. So now we gotta solve for friction force, which is what they want us to do in this case. So when we do that, we put this to the other side. This is gonna be negative. This is gonna be negative with our angle right there. So we get that when we put this to the side, we are gonna get that our friction force is gonna be the following. If we had real numbers in this case, we could just plug this in right here. But since this is just a theoretical questions, we don't really have to do that. Let's see, for the final answer we have right here is part H. Is the friction force less than, greater than, or equal to the weight? So for this case, friction will always be less because it's opposing the motion, and this cannot exceed the maximum force that can be generated between surfaces. So friction will be less because it's opposing motion, and cannot exceed the maximum force generated between surfaces. Okay, so friction will always be less than the weight. And that's it.